Welcome back. In this lesson, we are looking at the discriminant and what that means. And if you're wondering what is a discriminant, you've come to the right place because I'm about to tell you. So firstly, before we get started, remember last lesson we looked at the quadratic equation. We had that minus b plus or minus the square root of b squared over blah, 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 that mouthful. Yeah, the discriminant is part of that. So in the quadratic equation, the discriminant is the b squared take 4ac component. So the discriminant, as I've said over here in my little post-it keynote, is b squared minus 4ac. And we call this the discriminant. We use the symbol delta, which is the Greek triangle. We use that in physics a lot. They also use it in mathematics for the discriminant. We say that delta equals b squared minus 4ac. So what does that mean? So that means we can rewrite the quadratic equation here as delta. It's the square root of delta because delta was the b squared take 4ac. But what's the point of that? Other than making it easy to write, why do we care that the discriminant is b squared minus 4ac? The point that you might have actually discovered at the lesson starter from the previous lesson is that the discriminant has some significant effect on the solutions. And specifically, we have three outcomes. If delta is greater than 0, so if this b squared take 4ac gives you a number that's greater than 0, then square root of delta has to be a positive real number. That means that we have two distinct real roots, two solutions, and they're distinct. What that actually means in terms of the quadratic will be a little bit more obvious later on when we look at the actual quadratic function as a graph. But for now, in terms of the equation, it just means that there are two distinct values that solve the equation, that satisfy the equation. They're going to be minus b plus square root delta onto a and minus b minus the square root of delta onto a. So they're the two solutions. But in terms of the discriminant, all we care about is that if it's greater than 0, there are two solutions. On the other hand, if delta equals 0, minus b on 2a is going to be the only solution. So that's the only solution to this quadratic. And we call this a repeated or double root. And again, what this actually is will make a bit more sense later when we look at the actual functions on a graph. But for now, we just call it a repeated or double root. The third option is delta is less than 0. And that means that within the equation, we're going to have a square root of a negative number. And you can't do that. So far, hopefully, you've seen that you can never take the square root of a negative number. It gives you an imaginary number. It gives you a number that doesn't exist in the real plane. So if that is the case, if you get an imaginary number, we would say that there are no roots. There is no solution to this. There is no x value that satisfies this equation. And again, that will make sense later on when we look at functions. All three of these discriminant outcomes will make a lot more sense in terms of what they mean in kind of a real world or an application. So let's have a look at an example. Use the discriminant to determine the nature of the roots of 2x squared minus 2x plus 3. So remember the discriminant, the equation is b squared minus 4ac. So we're going to use that. B squared minus 4ac means we've got minus 2, that's the b, all squared, minus 4 times a times c, negative 20. Whoops. Negative 20. Therefore, as it's less than 0, no solutions. On the next example, we find that the discriminant here, delta, equals 40. 40 means delta is greater than 0. It's not a square, so there are two distinct roots. So, two roots. Good, two solutions. Again, showing some more sort of step-by-step processes, but really doing the same thing. Finding the discriminant using from that quadratic equation, and then interpreting it to say that, in this case, greater than 0, less than 0, no solutions, equals 0, one solution, or that double root that we're talking about. Another way to think of it is one solution. Let's get some practice. So there's another worked example here if you want to have a look at it, but otherwise let's do some practice. So in this case, let's just do all of 2. Yay! So again, we're finding the discriminant, State the nature just means what does that indicate? How many roots? Are there no roots, one root or double root, and two distinct roots? Check your answer then by solving the equation. So using the quadratic equation again, check that you do end up with two answers, no answers, etc. And then that's pretty much repeating the process. And then we get down to here, using only discriminant, using only discriminant. So have a go at those. Solutions will be on the next page in just a moment. And these are the high quality 10K solutions to the previous questions. The next set of questions we're going to look at is very similar, determining the number of solutions using the discriminant. I'm going to cull this down a bit, so we use 1. We'll use this. Oops, I deleted my own questions. Find the exact solutions using the quadratic formula. Bit of recap. Exact solutions using the quadratic formula. Let's just do these. We get lots of reps. Solutions are on the right-hand side in this case. So have a go at these, and then I'm going to move on to some more sort of application-y style questions in just a moment. So now we're looking at more of a sort of a visual representation. So in this case, a triangle's base is 5 centimeters more than its height of x. I think we actually did something very similar to this a few lessons ago as an opener. We know that the triangle's area is 10 centimeters squared. We want to find the height. So use this concept of what we've talked about, generate a quadratic based on this, see if you can find the height of the triangle. Then it says to solve the following using quadratic formulas again. So in this case, let's just do bottom row, because we've done plenty of practice at this. The only thing that they're trying to throw you off in this case is it doesn't look like a quadratic. So you just need to move things around, which is why that algebra stuff that we've talked about is so important. And then lastly, again, two more sort of problem solving style. Two positive numbers differ by 3. The product is 11. Find the numbers. And find the exact perimeter of this right angle triangle. Exact perimeter. There's a trick to this one in case you're wondering. Alright. Lastly, if you feel like a challenge, these are challenging questions. So if you want to have a go at them, by all means. If you feel like at this point you're sort of a little bit overwhelmed, or you feel like this is really testing you, you don't really need that additional challenge, that's okay. That's fine. But if you want, have a go at question 13. There are some more challenging questions here. So what this is doing really is, and this is a really common thing that you'll see at sort of uni and higher level maths, is more of this sort of generalized version. So you've got an expression here, but C is K. And so then they want to say what value of K, or what value must K be to have no solutions, one solution, two solutions. You've got to think about, well, what does that mean? How do I know if it has a solution or no solutions? What does that imply? Therefore, what numbers must K have in order to satisfy that condition? I don't want to give you too much more than that, or it'll kind of make it really easy, because that first couple of steps is the hardest part. So have a go at those questions. The solutions are on the right-hand side, and I will see you next lesson.